All right, so here we are back at, what are we doing? Normal distribution stuff. Normal distribution. Forgot what I was doing.
That's a good question.
Yeah, right? Psst, ladies, let's do this. A random variable x is normally distributed with mean, mu, unknown, In the following diagram, the shaded region between 9 and mu represents 30% of the distribution. I'm a big fan of writing in my pictures. Well, if mu is the average, then what's over here? 0.2, which is actually what the question asks you to find. Because it has to add it to 0.5 over there, so we know that this is 0.2. Easy peasy lemon squeezy. The standard deviation is 2.1. Find mu. Well, that's going to use the standard deviation equation, which is in the reference sheet right there, because we know the standard deviation is 2.1. We know the x value is 9. We don't know this. And wait, no. This is the standard deviation is 2.1. Yeah, that's a z. What don't I know? The z-score. So how do I find it? Inverse normal. Yep. So we use inverse normal right here to find a z-score that's associated with the number 9, which is what we're going to write in for right there. So inverse normal will give us back the value on the quote-unquote x-axis. Second vars, inverse normal, area is 0.2. We don't know our mean. We don't know our standard deviation, so we just do it like that. That tells us we are we are 0.842 standard deviations to the left of mean. That's what we know. So negative 0.842 is our x value minus our unknown mean divided by the standard deviation that we were told, and then we just get mu by itself. Multiply, subtract, divide by -1. So times 2.1, subtract 9, multiply by -1. Our mean is 10.8 to 3 standard deviations. Sig figs, wow. 10.8 to 3 sig figs. Not too bad, right? Okay. So far, so good. Let's see what we got next. The random variable y is distributed normally with mean lambda. That is a lambda, right? Is that a lambda? Okay. With mean lambda and standard deviation 3.5. The events that x is greater than 9. Wait, what's the probability that x is greater than 9? 0.8. There we go. I'll use a different color, but from here to forever is 0.8 because we've got this 0.3 and we've got this 0.5 over here. And y being greater than 9 are independent. Okay, so we know the probability that x is greater than 9, it's 0.8. And we don't know the probability that y is greater than 9, however, we do know they're independent. What does that tell us? You should be able to just straight multiply them. So this 0.8 times whatever this probability is had better give you 0.4. So dividing both sides by 0.8 gives us that the probability of y being greater than 9 is literally 1/2. Let me ask you a question. If it's, what's wrong? What? Oh, yeah, we have to find lambda. Yeah. So, well, let me ask you a question. If it's a normal distribution and exactly half of it is to the right of a number, what number are we talking about? The mean. So lambda must be 9, not 0.5, yeah. So lambda must be 9. Again, why is it worth so many marks? Just because of the realizations that it comes with. So you get a mark for knowing this was 0.8. You get a mark for knowing that you should be able to multiply. That's 2 marks. You'd get a mark for finding this. That's 3 marks. You'd get an implied mark for recognizing that that represents the mean, and then you get a mark for the final answer. If I had to guess, I'd say that's where those 5 answers came from. 4 of my fingers made it into the picture. There we go. That's where those 5 marks would come from if I had to guess. But unless you guys can see a hole in my logic, I think we're pretty good here. Pretty good? Okay. All right. Given that y is greater than 9, I'm going to be honest with you, I kind of need a picture. I've been keeping too much in my head. So let's do this. We know that lambda is right here. It says, given that y is greater than 9, sounds like conditional probability to me. Find the probability that y is less than 13. Well, how do you think we're going to do that? We're going to find the area less than 13. Okay. And what does that normally require? If we're trying to find the area less than something? Binom, not binom. Normal. It takes normal CDF. And we're trying to find the probability that y is less than 13, right? So we go, okay, on second vars, normal CDF. The lower bound, we're not going to give it a, well, we could give it a lower bound if you want to. Because, oh no, you didn't, never mind. No, so lower bound of wherever. Let's be careful. Let's just go ahead and, yeah, let's not. So the upper bound is 13, right? The mean we now know is 9. And the standard deviation was given to us is 3.5. That is the probability that a number is less than 13. So that's 0.873-ish. So all of this represents 0.873-ish. So if this is 0.5, this is 0.373-ish. This statement now, I think, would be the safest thing to do would be to write it in the conditional probability format. It says, find the probability that y is less than 13 given that y is greater than 9. I've written way too large, so I'm just going to go vertical here. The formula for that is the probability that y is less than 13 intersect the probability that, actually I shouldn't have written it like that, should I? I should have written it like that with one probability. There we go. So the probability of y is less than 13 and y is greater than 9 divided by the probability that y is greater than 9. There. So what is the probability that y is less than 13 but also greater than 9? This 0.373 right here. You okay with that, Chris?
Less than 13.
Yeah.
Yes.
Okay. So 0.373 and divided by the probability it's greater than 9, 0.5. There you go. And what is that? So I just need to subtract the 0.5 to get that 0.373 that we talked about. Then I'll just divide that by 0.5. There we go. 0.747. Yes, I can round. That question's neat. That's definitely not a number 8 on the old scale of 1 to 10. That was definitely a 9. I'd say definitely a 9. On the calculator? Oh, yeah. I guess while he's writing that, I'll do attendance. So, no. Kylie. And is Kylie the only one not here? that it? Oh, yeah, the reason why I'm making the video. Cool. We good now? Moving on? Cool. Let's move on now. Oh, okay, so my old test. Fun. Let us do this. Bonus dias. In a large city, the time taken to travel to work is normally distributed with unknown mean and unknown standard deviation. Uh-oh. We don't know mean or standard deviation. We're probably going to have to find both. That means there's a good chance we're dealing with a system of equations using the standard deviation formula that's in the packet. It is found that 4% of the population takes less than 5 minutes. So let's define a variable. Nah, screw it. The probability that x is less than 5 is 0.04. Watch your decimals. 70% takes less than 25 minutes. And they'll find the two things. You could, if it would help you to see it, then definitely go for it. So clearly 25 is to the right of 5, right? Picture not drawn to scale, so let's say 5 is here, and let's say 25 is here. We know that this zone right here represents 0.04. And since this whole zone represents 0.7, all we have to do is subtract to figure out what's between the two numbers. I don't even know if that's useful. I'm just going to throw it on there for visual people. That gives us 0.66, right? I didn't check on my calculator, which I should have, but it works. All right. I don't think the 0.66 is incredibly useful unless you have one of the newfangled calculators that can do the between setup for inverse normal. My calculator can't, so I'm going to have to do it the old school way, which is fine because not everybody has the newest operating system. We don't know mean or standard deviation, but we could use the standard normal. We could use the standard normal distribution to figure out what kind of z-score is required to have 0.04 to the left of it. So that's what we're going to do. So inverse normal will take that area and give us back a z-score because this is the standard normal, 0, 1. So this gives us a z-score. That z-score is negative 1.75 to 3 sigs. So what we know is negative 1.75 is our x value. I'm just filling out this formula. No, I'm just saying for video purposes. That x minus this unknown over this unknown. And then we just do the same thing with 25 to figure out what its z-score would have been. Now the area is 0.7, nothing else changes. 0.524. It's going to be a system of equations. 2 equations, 2 unknowns. Out of curiosity, anybody with the newer operating system, does your inverse normal do a left, right, center?
Yeah. I got it. It gave 2 values, like the same value. One's positive, one's negative.
Did it give you these two? I don't know.
0.66 is
What did it give you?
0.66 was the area.
Yeah.
0 standard deviation.
Mm-hmm.
I got negative 0.95 and positive 0.95.
Okay, what it did was it gave you how many standard deviations to the left and right of an unknown mean you would be going. So it told you your point, in order to get the exact same area, it centered it at 0. So it said if you wanted to know what it takes to get 66%, you're 0.9 standard deviations to the left and right of mean. So it didn't really help all that much either way. So I guess this would have been the way to do it. I don't know how to use that because I don't have it. So yeah, we're just going to multiply both sides by sigma. negative 1.75 sigma equals 5 minus mu. And 0.524 sigma equals 25 minus mu. And I like elimination, so because I don't like to substitute. So for me, I would have just stacked these two things. Bring this one to underneath this one, 0.524. Because if you subtract straight down, this negative mu minus negative mu actually says negative mu plus mu, which cancels. And I just need to figure out what that is. So calculator, this thing minus this thing is negative 2.28-ish. And then obviously just divide both sides by that decimal. I love second answer. Looks like the mean is 8.79. Standard deviation, excuse me, wrong variable. 8.79. Yep, and now you just take that sigma and plug it into one of your two formulas. This one's not been used up, so I'm just going to throw it right there. My phone just made a noise, but the screen didn't light up. Why? Oh. Nah, it's Reddit giving me updates. 0.524 times the number we just found. And just getting mu by itself. So take that number, multiply it by the 0.524 that we had on the screen. Subtract the 25. And then multiply by negative 1. 20.4. There it is. 8 marks for all of that crap. I think that deserves 8 marks. It's a lot of work. Those system of equations using standard normal stuff is, in my mind, pretty advanced. No, he had it. It didn't help him. What it did was it told him if you would like to cover up 66% of the data, but still be centered around mean, you'd have to go 0.9 standard deviations to the left and right of mean. That would give you 66% of the data. That's all it told him, which didn't really help all that much. Skirt. The heights of a group of 7-year-old children are normally distributed with mean 117 and standard deviation 5. Just reminding you that you're supposed to do sigma squared in that setup.
If you were to line up all the kids,
What?
put the tallest ones in the middle, do you think it would be like a bell curve? Like every other left?
I don't know. A child is chosen at random. Find the probability that this child is taller than 122.5. This was very straightforward. You legitimately just use your calculator with normal CDF. Our lower bound is 122.5. Our upper bound is huge. I don't know. I just throw a bunch of zeros on there. Mean is 117. There we go. There we go. So about 0.136.
Is it not possible to input the like 1 to the e negative infinite or whatever when you're looking at like upper and lower bound?
You could. Yeah, I don't know how. Yeah, I don't know how to make this thing type scientific notation.
Oh, it's the second column.
Second comma.
Yeah, it does e.
Hold on, I'm looking for comma. Oh, there it is. Okay, cool.
Yeah. So
Oh, okay, so you just do,
yeah, 1 second comma, that'll be 99.
just out of curiosity, second vars, normal CDF, because, so 122.5, then for this number, let's go ahead and clear it. Second, comma, oh, I forgot to type 1.
Yeah, 1.
Do I have to do times?
You don't have to do times, no.
So I don't even need that then. I can just do second E.
Oh yeah, I guess, yeah.
Second E to the
99.
99.
Because you can't go to the 100.
And let's see what happens. Okay. So as long as you use enough zeros. But now we know. Second E99, because I didn't know that. Thank you very much. So 0.136 is what we got. The heights of a group of 7-year-old children, no new information, child is chosen at random. The probability that the child is shorter than K is 0.65. Solve for K. So here's what we know. We know it's to the right of mean because this number is bigger than 0.5. In fact, it's 0.15 bigger than 0.5. There we go. All we need to do is use this thing again. But we need our z-score. We need our z-score for that 0.65. So let's go ahead and grab calculator. Second vars, inverse normal, 0.65. Oh, wait. What am I doing? No, we know our mean and our sigma. Yeah, mean is 117 and sigma is 5. That should be the answer. Okay. The 3 sig figs, I guess that's 119.
Probably then plus it's the full chunk.
Yeah, but these are heights.
That's height.
So it would have been okay to say 118.9. That's 4 sig figs. That's more correct. Yes.
The ones that
I did it like inverse normal 0.15, 117.5, and then to the right, and I got to 122.
But the right doesn't have 0.65. To the right is 0.35.
No, but the upper bound is
If you're going to go to the right, your upper bound is E99. And your area is 0.35.
But doesn't it just go stop at where the area ends, like 0.15, and find the...
No. So here to here is 0.15. You would have to tell it that the lower bound is this and the upper bound is that. But no, that wouldn't work. If you wanted to go to the right, you mean to the right of the number you're talking about. So if you want to go to the right, change your area to 0.35, and I bet it'll give you the same answer as what we have. Yep, okay. Yeah, it means to the right of the number you're talking about. Okay. One of these days, I got to update the operating system on my calculator. This question, I remember this question just giving you guys loads of headaches. A random variable is distributed with mean of 150 and sigma of 10. Find the IQR. So in order to find the IQR, you have to remember that it's Q3 minus Q1. This is a remarkably easy question once you realize where to find Q3 and Q1, how to do it. So if you were to draw it, you've got here and here. If this is Q1, how much data is to the left of Q1? 25%. And how much data is to the left of Q3? 75%. So all we need to do is use inverse normal with the given information to find Q1 and Q3. So let's do Q3 first because we know we're going to do Q3 minus Q1. Yeah, I said that right, inverse normal. Our area to the left of Q3 is 0.75. Our mean is 150. Our sigma is 10. And it'll give us this number. Now let's find Q1. Second vars, inverse normal. To the left of Q1 is 0.25. It is really this easy. So your IQR is literally the difference between those two numbers. You could show so little work. It's one of those questions that masquerades as difficult, but it really isn't. The IQR is 13.5. A 7-mark question that could be done that fast if you understood.
Would you be able to write just 13 because it's between three significant pieces, like one?
Oh, yes. Yeah, so if you said that Q3 was, well, no, you'd have to say 157 and 143, so you'd have to say 14. Yeah, so if you used 3 SIGs for Q1 and Q3 and then subtracted, you'd still be 100% correct.
Okay.
Yeah, and I bet the mark scheme even says in parentheses, IQR equals 14 if 3 sig figs. It was like if 3 SF is what it usually says. But yeah, that question, 7 minutes. 7 minutes that you can get that done in, if you understood the assignment, less than a minute. It's not that you're not supposed to show work, it's that you didn't have to. So you're going to get recognition of the fact that you needed Q. Okay, so you're going to get a point for knowing this. You're going to get a point for finding Q1, a point for finding Q3, a point for, there's like recognition marks. You could have shown the whole using the Z-score crapola to do that kind of stuff. Like it's not, there's a lot of stuff you could have shown that you didn't need to. It's very, very easy. It looked remarkably difficult. It's a very easy question. Oh, look, it's the giant tree question. A forest has a large number of tall trees, and if one falls, okay. The heights of the trees are normally distributed with a mean of 53 and a standard deviation 8. I'm just going to go ahead and do that. Don't forget you're supposed to put a squared on your standard deviation. Trees are classified as giant trees if they are more than 60 meters tall. Tree is selected at random. Find the probability the tree is giant. So what we're asking is, what is the probability that our x is greater than 60? So you literally just go directly to normal CDF. Lower bound is 60. Upper bound is, I'm going to use the second E99. Wow, that's so nice. Mu is 53 and sigma is 8. And that makes, I love that. It makes me so happy. Thank you for that. 0.191. Mm-hmm. Oh, you just change it to scientific? Yeah. Alrighty, that was an easy 3 marks. A tree is selected at random. Given that, oh, there it is, conditional probability. Given that the tree is giant, find the probability that it is taller than 70. Don't fall into the trap, okay? Let's actually fill it out. We're saying find the probability that x is greater than 70, given that it is giant. It's only 3 marks. Let me ask you a question. Giants are classified as anything greater than 60, right? So what would be the point of me saying the probability that it's greater than 70 and is giant? Like it's a moot point. But
well, if it's more than 70, it's probably more than 60.
Exactly. So here's how this works. The probability, the probability that it is greater than 70 and it's greater than 60, it's like, that's so stupid. And then you go, oh, divided by the probability that it's giant. Yeah. So really all we needed to do, see, because this was dumb to say. Because if it was greater than 70, it was automatically greater than 60. So we just kind of don't worry about that. Because that would be like, you know, what's the probability that I'm a teacher? Given that it's me. Yeah, you know. It's because they're just trying to trick you. What they wanted you to do was figure out this and then divide by this. So here's what you need to do. Figure out this number and divide it by 0.191. That's all you need to do. So our vars, we go down to normal CDF, and we just change the lower to a 70. And that's it. Nothing else changes. You get that number right there. And then you just divide that number by the 0.191, which is right here. It's going to be about 0.088. That is actually 3 sig figs, because the third significant figure was a 0. So I don't think IB will punish you if you don't write the 0 at the end. I think what chemistry would, right? You had to do 0.0880.
They did at the beginning of the year, but now she just doesn't care.
I wonder, oh no, I'm saying the IB graders. I wonder if they care. Chemists care. I don't think IB cares. Because even they know sig figs is baloney.
I mean, it's stupid. Just do until you feel like it's
Yeah, and I believe question 4 continues. It does. 100 trees are selected at random. Okay, we were just told how many trees were chosen. Shift gears.
it's not like a certain number.
Binomial, probably binomial at this point. So okay, we go. Find the probability they're both giant. Oh, this is just the probability of giant and then the probability of giant. So what do? Yeah, we just take the probability that's a giant and square it. Because it's 0.191 times 0.191.
I'm gonna, instead of de-squaring it, I'm gonna add a giant amount of times.
It's going to add it a giant amount of times. Funny.
Well, yeah. So what probability of giant are
0.0364.
Show me, write that out. I do that.
I don't know.
Dot, 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 and at the end it'll say giant. 100 trees are selected at random. Find the expected number. Okay, how do we do expected number? NP. So that's 100 times 0.191, or 19.1. If I remember correctly, and this is one of the things that I've never agreed with, so 19.1 is the expected number, but I want to say that they said it was 19.
Did you say that the expected can be decimal?
It should be able to be a decimal. I'm going to leave it like that. Yeah, I'm just going to leave it like that and say,
Maybe it's because there's a difference between expected number and expected value.
Nobody's gonna understand what you're trying to do.
expected number and expected value. No, it's NP. It's NP.
They're both the same thing.
Yeah.
What kind of game are they trying to get at?
I'm going to leave it at 19.1. What's that?
Maybe because it can't be 0.1.
Right, but if you roll a die, the expected value is 3.5. You can't roll that. It's not possible.
What if you get the dice stuck? So it's between the
This guy. Alrighty. Find the probability that at least 25 trees are giant. So at this point, we're saying that we're trying to, and this is binomial CDF. Cool? So what let's define a new variable. Y is distributed binomially with 100 chosen and the probability of success being 0.191. So we're trying to find the probability that capital Y is, if you say at least 25, what are we saying? Greater than or equal to 25. However, my calculator does not do binomial to the right. So 1 minus. There you go. Cool. On. Actually, you know what? 1 minus second vars binomial CDF. Please don't write binom PDF, CDF, things like that on your test. I'm just going to keep that saying that. No, it just
What's one of the things is like, oh, they need to demonstrate this, they know what binomial CDF
Well,
is.
if you get the answer, I'm pretty sure that is.
there you go. The probability that at least 25 of them are giant is not very good. It's less than 9%.
That's so sad.
Well, think about it. The probability a tree is giant is only 19%. So it should be pretty uncommon. Deforestation. Does question five must, oh, okay, we're going to finish this today, aren't we? 3-4 minutes. Let's see if we can do it. The time taken for a student to complete a task is normally distributed with a mean of 20 and a standard deviation of 1.25. A student is selected at random. Find the probability the student completes the task in less than 21.8. No, it's just a binom, or it's just a CDF, normal CDF.
Could you slide up for a second? Okay, thank you.
Yep. Okay. Equals normal CDF. And our lower bound is good. Our upper bound is 21.8. Mu is what? 20. And standard deviation 1.25 is, give it to me now, 0.925. And then the very, very last question, the probability that a student takes between an unknown number and then 21.8. Wow, that's one of the worst bell curves ever.
What did you use for the last question?
Normal CDF because we're going to the left on a normal distribution. It says the space between them is 0.3. Find the value of k. Didn't we just figure out what was to the left of 21.8? 0.925. So what's to the left of k?
I don't know.
Yeah, so the probability that x is less than k is just 0.625. So how do we take an area and get back to a x value? Inverse normal. Second vars, inverse normal. Area is 0.625. Mean of 20. Wait, what was the mean? 20 and standard deviation is 1.25. Yay! 20.4 is 3 sig figs. And we're good.
Okay, let's graph that.
I'm not graphing anything on it. I already did. We saw it on Desmos already.
Let's watch that video.
Watch the video of us learning math.